Okay, Saxon 4 Math class. Today we're going to be talking about Lesson 73, Geometric Transformations. And to start off today, we're going to watch a brain pop video on this topic.
Hey, could you pass the milk? Whoa, I didn't know you could teleport stuff. What happened? Well, we'd better figure it out. Mom's gonna be really sore if I'm all, sideways when she comes home. Aha! Just as I suspected, your transformation circuit's all out of whack. Transformation is the movement of shapes in 2- and 3-dimensional space. There are 3 basic transformations: translation, rotation, and reflection. All of them create symmetry, a repetition of shapes on a plane or in space. Well, you can see symmetry all over the place. The natural world is ordered in symmetric patterns. And people imitate those patterns in everything from artwork to household items. Well, when you teleported that milk carton, that was translation. That's when you just move a shape from one place to another. Translations can be described by 2 things: direction and distance. From the look of things, what you did to me was a rotation. That's when you turn a shape around a single point, like the hands on a clock. Why don't you zap me once more just to make sure? Whoa, stop! Ugh, I think I'm going to be sick. Anyway, looks like I was right. You rotated me around a point in my belly. Any rotation can be described by its center point and its rotation angle. Maybe you can just rotate me a smidge just to get me right side up. You've made a reflection of me. That's a kind of transformation where you basically flip a shape over a line. A reflection is described by its mirror line, or axis. See, my hair's all backwards and suddenly I'm right-handed. Right. Okay, listen to me carefully. Reflect me back to where I was. Hey, you did it! Okay, now just rotate me a little bit to the left. Alright. Wait. You tilted the whole world. Well, this is bad.
Okay, so now that you know what those 3 basic translations are, let's take a look at our example 1. It says, which transformations would move triangle 2 to the same orientation and location as triangle 1? Okay, so I have made a little slide of this. And so basically what they're saying is, how could we use translations to get this shape exactly where this one is? Okay. Now, I was taught that the 3 transformations were slides, flips, and turns. But there's better language, better math language. A slide is called a translation. That's where you take any shape and you just slide it around. Imagine if this were a pattern block and you put your finger right on it and you were just sliding it around. You notice we did not turn it though, okay? The top is still at the top and the base is still the base. Now, a flip or reflection. My program wouldn't let me do it to show you, so I had to open up Microsoft Word. Imagine a line in the middle, and it may not be there. You may just have to imagine it, and imagine it as a mirror. Okay, so if you're looking at a mirror, what you will see is a reflection of that shape. Okay, and if you'll notice, I just turned it right over that center line. So it's like looking in a mirror and you see the reflection. Okay, now a turn picks a point and you just turn it around. Okay, this one is, the point is right in the middle. It could be over here though, or any of these points. Okay, and you just turn it around. You could imagine a pattern block and doing that with it as well. Okay, so back to our problem. Which transformations would move triangle 2 to the same orientation as triangle 1? So now let's try it out. I need to try to take triangle 2 and make it match right on top of triangle 1. So the first thing I'm going to do is a turn or a rotation. And let's see if I can get it right on there. And I did it a minute ago. Okay, yes. So just by rotating it around, I was able to get it to that orientation and that location. Now, I didn't just rotate it, did I? I also did a translation or a slide. So I had to do a little rotating and a little sliding. So the two are turn, slide, or translation and rotation are the better words. Now let's do some more practice. Now, congruent, same size, same shape. Anytime you see that word, I automatically want you to think of the little cheer. Same size, same shape. Congruent figures may be repositioned through transformations so that all corresponding sides and angles are aligned. Name the 3 transformations described in this lesson. Give the common name and the geometric name for each transformation. So if you remember flip, slide, turn, you can look back. A slide is a translation. A flip is like a reflection in a mirror. And a turn is like a rotation around a clock. Okay, there we have it. Now let's look at B. Which transformations would position triangle ABC, that's this one right here, on triangle DEC? That's this triangle. So if we kind of look at it sideways and we imagine a center line right through here, do you know what that would be called? It would be a flip, wouldn't it? Or a reflection. Okay. And you could rotate it, but then you would still have to reflect it. Now let's look at C. It says use a color tile to model a turn, a flip, and a slide. So you can actually do that and practice a little bit yourself. I've got some pattern blocks that you can try some different shapes, and I want you to try a slide, a translation, a flip or a reflection, and a turn or rotation. Okay, let's go back now. We're going to skip the facts today since we had the extra movie, and let's go on to the mental math. 12 times, oops, I'm on the wrong one. I do that all the time. Mental math for 73. 21 times 2, we know that'd be 42 and tack on a 0. Now think 3 times 25, tack on a 0. Think 2 times 25 and tack on a 0. Okay, with this one, think of the 19 as a 20 and go ahead and add that to the 48. Take away 1, add on 10, then add on 300. Julia has a gift card that is worth $50. She has used the card for $24.97 in purchases. How much value is left on the card? Well, we know this is very close to $25, right? It's 3 cents away. And then from 25 all the way to 50 is $25. So it's $25 plus that 3 cents. There you have it. The track meet started at 9 a.m. and lasted 4 hours 30 minutes. What time did the track meet end? Okay, so let's take 9 a.m. and count up 4 hours. And then add 30 minutes. Now remember that you passed noon and you've got 1:30 p.m. Okay, now we get to estimate. At sea level, sound travels about 1,116 feet in 1 second. Round this distance to the nearest 100 feet. So we look at the hundreds place and the digit immediately to the right. The 1 tells us to leave this 1 the same. So, and the 2 digits to the right will drop down as zeros. And so that rounds to 1,100 feet. Okay, here we go with calculation. The square root of 25 is 5 times 7, 35, plus 5, plus 10, divided by 10, then you're back to 5. Okay, problem solving. The charge for the taxi ride was $2.50 for the first mile and $1.50 for each additional mile. What was the charge for an 8-mile taxi ride? Explain how you solved your problem. For this one, I would love to make a table. Um, and so we will go for an 8 miles. So mile 1, 2, 3, 4, 5, 6, 7, 8. Those are our miles. And our cost. So the first mile was $2.50, right? And for every additional mile, we have to add $1.50. Okay, I'm gonna change colors here. So for the second mile, it's add on $1.50. That would be what? $4, right? Third mile, we add on another $1.50. For the fourth, after 4 miles, what do we owe? Add another $1.50. After the 5th mile, $1.50 more. After the 6th mile, we added on $1.50 more. 7th mile, and the 8th mile. And this would be our total cost for the whole taxi ride. Okay, and you also need to go back and check 72 written practice. So hit pause as you check 1 through 7. Sorry about that. Hit pause as you check 8 through 15. Hit pause as you check 16 through 30. And you are finished.